Hello, welcome to Dean's Electric. Today I will be looking at the Star Delta motor control circuit. A Star Delta motor control circuit, also known as Y Delta motor control circuit, is used to control the starting of three-phase induction motors. The primary purpose of this circuit is to reduce the starting current and torque experienced by the motor during its initial startup. This is particularly important for large motors because they can draw very high current when starting, which can lead to voltage drops, increased wear and tear on the motor, and potential strain on the electrical system. Now let us look at the wiring diagram for the power circuit. At the top left hand corner are the three-phase, line 1, 2, and 3, leading to the isolator, then circuit breaker, then main contactor, then overload, and finally the motor windings U1, V1, and W1. Next to the main contactor is the delta contactor. I also draw the delta symbol with the windings labeled for easy connection. If you look closely at the symbol, line 1 is connected to U1 and W2 winding. If I should trace line 1, it goes through the main contactor and connects to U1, and it also feeds over into the delta contactor and leads to W2. Look at the symbol again for line 2. It is connected to V1 and U2. By tracing line 2, you can see that it goes through the main contactor and connects to V1 and also feeds over into the delta contactor and leads to U2. Look at the symbol again for line 3. It connects W1 and V2. By tracing line 3, it goes through the main contactor and connects to W1 and feeds over into the delta contactor and leads to V2, and that is it for the delta connection. Next to the delta contactor is the star contactor, and for the star connection, all the ends of each winding are joined together. It is that easy, guys, and the only challenge you should face is if the motor windings are not labeled, and I will leave a link in the description below for the video I did on how to identify motor windings. Let us now focus on the control circuit. Line 1 and line 2 are connected to the transformer to step down the voltage from 415 to 110 volts. The live is then connected to the stop push button, then to the start push button, then to A1 on the main contactor. The neutral then goes to a normally closed contact on the overload, then to A2 on the main contactor. Next, there is a connection from the stop push button to a normally open contact on the main contactor, then to A1 on the main contactor. This creates the latch for the circuit to operate continuously. From the other side of the normally open contact, a connection is done at A1 of the timer, then A2 of the timer is connected to A2 of the main contactor. A connection from A1 on the timer is shared to a normally closed contact on the same timer, then to A1 on the star contactor. A2 of the star contactor shares a connection with A2 on the timer. Then there is an indicator light parallel to the coil of the star contactor to indicate when the star contactor has been energized. The connection that feeds the normally closed on the timer also feeds a normally open on the same timer, then to a normally closed pair of contact on the star contactor. The circuit can operate without this interlock, but I use it as an extra protection because I have seen cases where contactor fail to open and there will be a short circuit if the star and delta contactor are energized at the same time. However, the circuit can operate without this interlock. Then, from this normally closed contact to A1 on the delta contactor and A2 on the delta contactor shares connection with A2 on the star contactor. Next, the light is connected parallel to the delta coil to give an indication when the coil has been energized. Let us now complete the connection for this circuit so that we can see the operation. When the start push button is pressed, the main contactor will energize and close its pair of normally open contacts, which create the latch to keep the circuit running continuously. The timer will also energize on the star contactor as well, because it is connected to the normally closed pair of contacts on the timer. After 3 seconds, the timer will open its normally closed contacts and close its normally open contacts, resulting in the delta contactor being energized and the star contactor de-energized. In summary, the purpose of the star-delta motor control circuit is to provide a controlled and smoother startup process for 3-phase induction motors, especially larger ones. By reducing the initial starting current and torque, the circuit helps prevent excessive strain on the motor and the electrical system, thus extending the motor's lifespan and ensuring reliable operation. This is video number 4 of 8, therefore we are halfway through the 8-video series on motor control. Please stay tuned for the remaining videos.